Hey, I'm going to do this mapping problem to demonstrate how to actually find the distance between specific genes given some information about generations and their progeny. So I'm looking at this looks like fall 2007 exam 2, and we're looking at this fruit fly, Drosophila, and it has the yellow body, white eye, and cut wing, 3 link loci. And it looks like those are all the recessive traits, and the wild type is always going to be the dominant trait. Or instead of recessive, sometimes it's called mutant traits. So I'm going to oh shit, this has already been done. Alright, I'll just explain it. So the most popular two are going to be your no crossover. Okay, so we know that during it's going to be like anaphase, I think, like prophase, like maybe either metaphase or anaphase. You have crossing over between homologous chromosomes, but these are where there's no crossing over between the specific genes, right? And this is where we have double crossing over. It's missing. Okay, so basically these are the progeny produced, so we know we should have basically basically 8 different types of progeny, but we only have numbers for 6, but we know there's always going to be 8 whenever you have 3 different genes. 3 genes with 2 different alleles each makes 2 times 2 times 2, or 2 to the 3rd, which is 8 different combinations. These are all the combinations here. So we have no crossover here, and we know it's no crossover. Like, these have been filled in, right? So the reason that we know it's no crossover is because we look at those numbers. How long has that camera not been looking at this? I don't know. But we look at those numbers and they are the largest. And then we have some other sets of numbers that are smaller. And then we have 0 for double crossover, so it's the smallest. And so the way that you actually determine the order of these alleles here, or the order of the genes, is that you identify the no crossover and the double crossover, and you are given some information about the phenotype of these progeny as well as numbers. So that phenotype is going to allow you to determine their genotype, and then once you've determined the genotype, you can see where it changes between no crossover and double crossover. So in this case, we have YW plus, and then we have Y plus C. Okay, so the W plus sort of switched over. It crossed over, right? So the Y and plus are the only things that switched. And right now, the way that this is visualized, that's on the end. But this is double, right? The reason that we know it's double is because those are 0, and double crossing over happens much more rarely than single crossing over, or of course, no crossover. So we have to write this correctly, and to do so, we'll just write, instead of the order YWC, we'll put it in the order of WYC, or CYW. It's the same either way. We don't have a way of determining the, like real order. Maybe if we looked at a chromosome and we aligned it, in a specific way, we don't actually know the order, or we don't know the whether it be, WYC or CYW, but we definitely know that it's going to follow that order, and Y is going to be in the middle, basically. All right, so that's what we are showing here, therefore the correct order is WYC. Y is put in the middle because Y is what's changed between NCO and DCO. Y is what's been swapped, and so DCO needs to look like this compared to NCO. Then we are going to take these numbers and divide them by the total, add these up, divide by the total, add these up and divide by the total, same with these, and that'll give us our relative fractions of each sort of schematic or whatever, each group, I don't know. And then what we'll do is basically we want to measure how likely it is that a crossing over were to happen between two genes. So we already saw that NCO looks like this. So basically imagine that these are two chromosomes, or chromosomes, that's right. These would be two chromosomes on like two, I don't know, what's it called, sets of genes or whatever, on two homologous chromosomes. And so we're in like, what is it? Like either metaphase or anaphase. I think it's like anaphase. So we're in anaphase 1. And no crossing over is the most likely, but we can also have single crossing over 1. There's one way to do it, but there's also another way to have single crossing over, right? It's like that. So that's why we have SCO1 and SCO2. And then we have the double crossing over. And so basically what we want to measure is, how probable is it that crossing over happens between these two genes. And if they're close together, then if they're close enough together, then it's effectively a 0% chance that crossing over will happen between those two genes. And then if they're far apart, then, you get to where it's like 50% chance that crossing over happens. All right, so like I said, we want to find the relative probability that crossing over happens. So therefore, no crossing over, we can really pretty much ignore this from here on out, because we're only concerned with what is the probability that crossing over happens between, let's say, W and Y, right? So we know this is the correct order, WYC, so we're gonna find what's the probability that crossing over happens here and happens here. All right, so I wish I had written this the correct way. W, I'll just do this. All right, so these are our two. These are our two homologous chromosomes or whatever. And see, SCO1. So we want to find distance between W and Y. All right. So what we want to do is take the double crossover, because that looks like this. So that includes a crossover between W and Y. So W double crossover. What else contains a crossover between W and Y? This one right here does not, because we start with this. Hold on. Between W and Y. Yeah, okay. So this does contain a crossover between W and Y. Whereas this one doesn't? Hold on. All right, so because there's more progeny here, this crossover is more likely than this crossover, which means this crossover is a crossover between two genes that are farther apart. And we're looking at WY, and that's farther apart. So yeah, I'm correct. All right, so basically, if you look at this and you look at this, what's flipped? W, right? So it's between W and Y. All right. So, and our thing is WYC, so go ahead and write that out. So we got the double crossover plus SCO1 equals what? Well, pull out the calculator, and DCO equals 0. SCO equals, let's see, 290 plus 260. And then we take that and divide it by the total, which is 2,500. So you get 0.22, which is going to be equal to 22 map units. You just basically take that and then you just times 10, or I'm sorry, times 100, and you get the number of map units. And then 1 map unit is equal to 1 centimorgan. Same values for those units. All right, and then we have our YC, right? So that's gonna be, which of these have a crossover for YC? Well, we're starting with this. This is a no crossover. So YC, right, between Y and C. Well, if we have a double crossover, that would have crossing over between Y and C. That would actually have 2 crossovers between Y and C. Wait, no, it wouldn't, because we have WYC. So imagine this W is to the left of this Y. Then, yeah, basically, of course, SCO2 is going to have the crossover between Y and C. Yeah, because we're imagining this is just take that, put it in the middle of W and C. All right, double crossover. It's going to have crossing over because, well, first of all, it always does, but if we try to visualize it, then basically you have that Y flipping up. You're going from, yeah, that's right, I drew it here. So obviously this is a crossover between Y and C. So let's do it. That's going to be equal to 0. That's going to be equal to 26 plus 24 divided by 2500. So 0.02. Then it's going to give us 2 map units, or 2 centimorgan. And that's what we get. And that is how you find genetic distance. Just as a refresher, what we're actually finding here is like if this is a chromosome, then what we're finding here is that basically if this is the end of the chromosome, no, we don't know actually whether it looks like W, Y, C, or it might actually look like W, Y, C. But we do know it's in this order, and we also know that Y and C are 2 map units away. So it's going to look more like, if it's in this order, right, it's actually going to look more like W, Y, C, you know, because this is 22 and this is 2. So this is 11 times greater than this. Same with this. If this is what it's actually looking like, then it's going to look like this. All right, I hope that was helpful. Bye.